Hello, my name is Adam Morgan from AdamCode716.com. I'm coming from you on a beautiful late summer day from the outdoor studios of AdamCode716, located in beautiful Western New York. Today I'll be giving a talk on OpenAI's fairly new Assistants API, which is quite different than the API which you're probably normally used to using, which is the Completions API. Who's this video for? I'm going to be focusing pretty heavily on concepts today, although towards the end I'll be giving two demos and those will be a little bit more technical. If you're a developer and you're looking for a deeper dive on anything you're seeing here, there will be other materials underneath the video as well as on the page on my site that hosts this video. And I want you to also watch out on an upcoming video on semantic kernel. There's a lot of overlap between the OpenAI's Assistants API and semantic kernel, so that it would make sense that those would come together. So with that, let's begin. So to better understand the OpenAI's Assistants API, let's take a step back and talk about the nature of the evolution of intelligence. So at its core, AI is really the endeavor to teach a model to learn in the same way that humans learned. For example, when you were a child, you were taught, presumably by your parents or teachers, what an apple is. And given enough apples, you could differentiate them from other fruits. As time went on and intelligence grew, we gained the ability to predict. So, for example, it probably didn't take too long for humans to realize that if you looked up and you saw dark storm clouds, that a storm was coming. As time went on and our skills and knowledge increased, we could then look at things like barometric pressure or wind direction, things of that nature to predict the weather. And we see that in, if you watch the news and they talk about models, that's exactly what they're talking about. So they've seen what's happened in the past and they use those information points to predict what's going to happen in the future. And as time went on and our intelligence improved and we gained more skills, we became more proficient in problem solving. So for example, if we needed to build shelter or go to the moon or those kinds of endeavors that you would need a variety of things, among them tools to make the home or the spaceship and skills, to put those tools to use. Speaking of tools and skills, those are exactly the things that we need to, for example, build a home. To build a home, the first thing you need is tools. But the tools by themselves aren't enough. You need a skilled craftsman to be able to put those tools to use to make a home. And then as time goes on, the skills evolve as well as the tools that the craftsman will use. It's a never-ending process, and when you think about it, that's exactly what AI is. It's a never-ending process of building your skills and your tools. So, tools in AI. There's something called function calling, which actually isn't new, relatively speaking. Many large language models support function calling and have for a while. This allows a prompt to be hijacked, for lack of a better word, to perform some custom functionality. For example, you might call a web service, you might execute some custom code, you could perform a combination of tasks. For example, a common web service is get the temperature for a location. So we could call that web service and then say you get back the value 72 degrees. You could then take that value and then pass that to a second function or API or custom piece of code to convert that to Celsius. So that would be an example of chaining tasks together. Now, before the Assistants API, it was incumbent on the developer to provide the skill behind all these tools. So in the example I just gave, if you wanted to first get the weather and then convert it, you had to combine those two tasks together in the code. So let's talk about a specific example of function calling, and this is going to be a demo that I'm going to show you in a moment. So Again, this was all possible currently using function calling. So for example, if in our use case, we want to say turn all the lights and turn all the family room lights on, what we could do, there's a few different ways to do this. One, you could have used something like prompt flow to, to anticipate what the user would ask. You could use a software package like LangChain, where you can handle a variety of functions and chain them together. So what that logic would be, regardless of the tool, is that you would call an endpoint to get a list of lights. You'd query the endpoint to see which family room lights are off. And for the lights that are off, you would turn them on. So that last phrase, you see the word for, and if you're a developer, that probably rings a little bell. Yeah, that's a for loop. That's code. That's logic. So in this case, the developer would bring the logic to bring all these tasks together, to essentially chain them all together. So let's talk about all the things that would need to come together for this use case of turn off the lights in the family room. So up until this point, we haven't talked about anything that is specific to OpenAI's Assistants API. So for example, we might have a list of tools, or in this case functions, these 4 functions here. And first one, so you'll notice the function name in the first column, the input in the second column, the output in the third column, and the description in the fourth column. Get all lights doesn't take an input. You get back a list of lights. Get the ID of a light. You input the name and you get back the ID. Get the status of a light, requires the ID, and you get the output of status, and set the light state, where you'd be passing in the ID and actually the state as well. I should have updated that. And you're actually going to get back the updated state. So what I'm doing here is I'm actually using these functions, which you'll see in a moment in the demo, are actually pointing at my smart home ecosystem that is made by a company called Habitat. And that allows you to control your home automation via API calls. So we're several slides in, and we haven't yet talked about what makes the Assistants API such a groundbreaking innovation. So let's get to that. So in the large language models that preceded it, you would pass in a description about what your, who is the app, what persona are they taking on. Are they a very useful assistant? As a side note, probably twice as I typed that out, I typed "you're a very useful engine." You will pass up the user's prompt, which is what they're looking for or looking to do. And in the case of the Assistants API, you're also passing in a list of tools. And those tools are going to be what's available to the model. And we'll see what that means in a second. So here's an example of a configuration of a specific tool. So this tool is get light status. The description is get the current state of a light. So what happens is we pass up all these configurations for these tools, not any code, just a configuration. And those tools are then made available to the large language model, and they do that by looking at this configuration in general and the description in particular. So before we go too much further down this path, let me take a step back and highlight one of the other differences that comes along with the Assistants API / model that is different from earlier models and even different from other technologies. So one of the things that the model does when that prompt comes in, and if it comes in with a list of tools, is it looks at the prompt and compares it with the tools and decides if one or some of the tools should be used. Does the prompt match the description of those tools? If yes, then the model makes what's known as a plan. If no, then it's business as usual, and the model passes the prompt through just as you would see in a normal API call. One thing that's different is that in years past and even in other platforms is that you would have to tell the endpoint of the model that a potential call to a function was coming using a trigger. So, for example, in the case of an AWS skill, you might have to do something like this: Alexa, ask backyard for the pool temperature.
Pool temperature is 73.9 degrees at 3:47 p.m.
So in this case, I said, Alexa, ask backyard, and backyard was the trigger for the intent, which was the pool temperature. So the trigger, I don't want to say the name again, she's going to start talking. The word backyard indicated that the skill should have its ears up for an intent, which was the pool temperature API. So once the LLM has realized that the prompt was best suited for the tool or tools that were passed up to it, it will create what's known as a plan and then execute the plan. So this is something that's a little bit different than earlier function calls. In earlier function calling capabilities, you could pass up a list of functions, and the model would determine which function was right for you, and it would return the name of the function back to the code that called it. With the Assistants API, it's a little bit different. So with the Assistants APIs, it will create that plan, and then it will pass the plan back to the code that called it, and then it will execute the plan. So in this use case of turning on the lights in the family room, a sample plan might look something like this. You would make a call to get all lights to get a list of all the lights. For each light, call the get light status to find out which lights in the family room are on. And then for each family room light that is off, call the set light status to turn the lights on. And I'll just recall something that I mentioned a couple of slides ago. When you start seeing those words for each, you know that code is coming. So before Smart Assistants API, we had to write that code. We had to determine which endpoints or custom code we were going to call, and then essentially put wrappers around those calls. When we see these words for each here, it's actually the part of the plan that comes back that actually behind the scenes writes the code to do that and then execute those calls. I only, as the developer, only need to pass in the configuration. Smart Assistants API figures out everything else. That's probably enough talking for right now, so without further ado, let's look at a couple of demos. So with that, let's get to our demo number 1 of 2. So what you're looking at is something that a group of developers made called the Azure AI Assistant tool. That's on your left here. And this can also be used without Azure. It can be used as just about everything else. I'm going to show you a script in a minute where I'm going to be pointing at Azure OpenAI, but the script can certainly be modified in the client initialization to point just at OpenAI. So anyway, this tool is not my work, but what I'm going to show you in a moment, which are the functions, those are my work. And I'm going to show you this in an inline script in the second demo. So I'm in this utility, and I've created a couple of assistants. We're going to focus on lighting coordinator and not Bubba. So in here, I've defined a list of user-facing functions that are available to the individual assistants. So there's get pool temperature, get lights, and the next 4 are all the ones that we looked at in the previous slides. So for example, if we look at get light ID, this top part is what's optionally passed to the model in that payload under the tools area that we saw a couple slides ago. So it's using this description that the model will determine if this function should be used, or functions should be used to satisfy the prompt from the user, or should it just pass it right through the model. and let the model answer the prompt and not use any tools. So this top area is what's passed to the model. This bottom area is the code that corresponds to this function. So this getLightID, and then the definition of this Python code is getLightID. And what this does is this is calling an endpoint on my Home Assistant platform, which is called Habitat. And for those of you that are familiar with Habitat, and you see my access token there, don't get too excited. It's not going to be there for more than another 20 minutes. So I don't mind you seeing that right now. So this code is very straightforward. You're passing in a light name, the name of the light. So for example, table light 1, which you see over here, or table light 2. And it's returning back the ID. And if you recall back to the functions list, let's look at another one. Let's say if we want to set the light state requires that the light ID be passed in and not a name. So one of the things that the model needs to do is, assuming that the user passed in the name of the function, not the ID, which they almost certainly would, they're not going to know that table light 1 is ID 623. One of the things that the model can do is see which function it needs, see if it has the information for that parameter, in this case light ID, and if it doesn't, can it go find that? So in the case of, if I want to turn off table light 1, the model would need to know and get call this function, get the light state, or I'm sorry, it would call a different function to get that. I forgot to change function here. So it would call getLightID to pass in the name, and then you get the light ID back, and then you could then take that function or take that value and set the light state. So again, I would have gotten that light ID back, and it's figuring all this out in the plans that we looked at earlier. So what I've done here is I've created an assistant. Let's look at that. Oops, sorry. So there's the lighting coordinator. So here's the instructions, as we talked about earlier, that every bot or application, you can pass in instructions to the model so that it has some level of context about who the calling application is. We can assign the user functions that we just looked at to this assistant. Now if it doesn't have it in its configuration, it's not going to be available to the model. And then we can pass in some other values, developer facing stuff such as temperature or tokens. Okay, so I've selected the lighting coordinator assistant. I've opened I have a thread open. So one of the cool things about this Smart Assistant package is that it maintains, so when you start a conversation, you're assigned a thread ID, and you can programmatically reference that thread ID. But in the case of this utility here, we can actually just jump from thread to thread to thread. So let's go ahead and start interacting with it. So show me the status of table light 1. So again, this would have to take the user-friendly name, call the getLightID function to get this ID back, and sure enough, that was the ID 236. Turn table light 1 on. So again, it's converting that friendly name to an ID by calling that function. And then it's calling the setLightStatus function to turn it off. So over on the right here, I've got the log for this Azure AI Assistant tool. And then down here, I've got the live server logs for my Habitat installation. So I can see that I passed that command to the API, and it turned it on. So a different command here. I don't have a function called family room lights or anything like that, but I do have a function called getAllLights. So in this case, and I'm not, I could parse through all this. This is a running conversation with the model. So there's a lot of information in here. In here, buried in here is the plan. If you analyze some of the information here, but what it's done in English is it realized that it needed to get all the lights. It got all the lights. It then looked for the family room lights, which is a parameter in that return JSON table. Found those lights, then looked to see which ones were on, and turned those off. And this is so powerful. So you're probably already thinking of the business-like applications that this would have. For example, if you had an online ordering system and you could, take an order through this, and the user might say, I want to buy X, Y, and Z and ship it to here and yada, yada, yada. So anyway, if you passed it all of the functions that are available, it could piece together all those functions to perform an action that you want to happen. For example, it could update the orders table and then create a new customer in another table, and so on and so forth. Really, the possibilities are endless. You're really only limited by how many functions that you can pass in. I don't remember that number off the top of my head, but I believe it's a lot. So as you can see, there's a lot of functionality here. And the cool thing about this is that you've in other areas in function calling, you were very limited. That you had to look for very specific things. You had to look for that trigger, or not so much the trigger, but the intent. And you were kind of limited to that function. Get me the weather for San Francisco. Tell me the time. You were calling a very specific endpoint. You're limited to this. But I could keep going with this model, this information table. So now we can do all the cool things that come along with the model. I could say regurgitate this and talk like a pirate. I could say speak these out loud. I could have once it's seen those payloads, I could start asking it other questions that are completely outside of the configuration that I gave it. So really, just some really powerful stuff here.
So I wanted to do a second demo to give you an idea of what this code looks like in line. It's really not much code, and probably about half the code that you're going to see here is really only used so that we can print out the conversation as it's happening, and be able to inspect it that way to get that visual. This is not my code. This is a very common example, uh, getting the weather for a given location. As I've mentioned before, I'm currently pointing at Azure OpenAI. It's literally, I don't know, 3 to 5 lines of code to point to regular old OpenAI. You can find lots of examples on how to do that. It's really just around initializing the client. Once you do that, it doesn't matter if you're pointed at OpenAI or Azure OpenAI. So this is the custom code. This is my function. Again, I could have as many functions as I want, up to the limit for the model. Currently, I just have one. If I wanted to, it's not uncommon to have these functions in a separate file, so that you don't have to update your code. You can just update the other area where your functions are defined. We've just got some handlers here to handle the conversation threading. Again, a lot of print statements and the like. I'm going to come down here. Again, another trying to make it easier for you to read and understand what's going on with the conversation. But at the end of the day, the code is really here. I mean, this is really where all the magic happens. This area here. So what I'm going to do is I am going to execute this, and it's going to ask what's the current weather in Paris, France. So what the code is doing is it's inspecting the progress as the conversation happens, as the model does its work. and I did print out a string here, the results of the run, and it says that the current temperature in Paris is 22 degrees Celsius. So what's here in this string is I've copied this ahead of time so that I don't have to parse this in front of you. The required action, this is what the model determined it needs to do to satisfy the prompt. So in this case, it would be calling the function getWeather. If it didn't find a function that best suited the prompt, it would have just returned none there. So it's determining there that as part of its plan, it needs to call getWeather, and that's what it did, and that's where how it got this result. So we can continue the conversation. We talked about the idea of threading. There's the conversation threads. So if you wanted to ask it a follow-up question, um, convert into Fahrenheit degrees. Because it's a conversation, you don't have to remind the model what that context is because it's in scope of the conversations. So I'm going to run this, and I've done this a few times, and I've gotten different results, which it's still accurate. But what it does is sometimes the model will return just whatever it thinks you might find interesting. So okay, so in this case, it actually printed out the plan as I hoped it would. So it created a plan um, that involved the formula for converting Celsius to Fahrenheit. Now, in earlier in this lecture, we talked about plans, and I think I probably put it, kind of in the guise of that plans are related to functions, and they're absolutely not. So in this case, it created a plan, a mathematical plan in this case, without any kind of function. It just knew that it needed to do that. So if I can try to click this again, see if I get a different result. Okay, and sure enough, the same result. Maybe a little bit different. And that's going to lead to something I'm going to touch on in a moment, the pros and cons of smart assistants. So just a couple more slides. There are a couple more capabilities that are built into the Assistants API. So the first one is file search. So what this allows you to do is to either point your assistant at an existing vector store or at runtime allow the user to upload a file that will then be populated into an existing vector store. It's actually kind of frustrating for me personally that this has come along because earlier this year I had made a container app which allowed a user to upload a file and chat with that file in its own session, but was considerably more work than it would have been to simply use the Assistants API. The second one is Code Interpreter. This one's pretty cool, and you may have read a bit about this one in other areas. So the code interpreter will allow you to create code and actually write that code to a file, or even optionally execute the code. For example, let's say you wanted to perform a series of operations, maybe parse some data, um, maybe parse the file that you just uploaded. So you could have the code read that file and, for example, run some Python to generate a bar chart based on the data in the file. That's an example of something that you could do with a code interpreter. So you're probably going to hear more about this in the news if you haven't heard it already. There are companies advertising that they are having their AI write entire applications, so it would certainly use the functionality in this area. So in this presentation, we've spent a lot of time talking about all the great things that the Assistants API can do. Um, one use case that I've been working with the client on creating is having a giant list of functions in a central location, and then in the various bots having it parameterized so that you're only pulling in the functions that you need to pull in at runtime so that you're not passing all the functions to Assistants API. So there's obviously a lot of good that you can do with the Assistants API, but as with so many other things in life, it comes at a cost. In this case, it's a literal cost. It's not cheap. In fact, it can be very expensive. I've seen some estimates that say even $1 a call, depending on how much you're passing back and forth. And you are sending a lot of information back and forth. I think we saw that in the one demo where I had the debug window open, and you just saw a ton of text going back and forth because it is a conversation. In that sense, it is stateless. And then probably the second biggest pitfall is that while you can provide some level of guardrails, although they've since removed some of that, by including directions in the tool, you're still largely at the mercy of the model that you're using. So even in that last demo at the very end, I said that I gotten different responses back. It always converted the Celsius to Fahrenheit correctly, but once in a while it told me, it decided to tell me the weather in an area that I didn't ask for. And you'll see if you've worked with AI and models a lot, you'll see a fair amount of that. So, are you going to want to put your business critical functions in smart AI? No. And I think anytime you go out to a chat bot, it tells you that, this is all still experimental and not perfect, and, it might not act in the way that you want it to. So, definitely use any of this with caution. So that's it for the presentation. As always, I thank you for taking the time. If you like, subscribe. There's plenty more videos coming. I plan on making this a regular feature. And speaking of AI, it made a representation of me with the man that has much more hair than I do, and much darker too. So if you like this presentation, please give it a like and subscribe, and there will be a link to the various materials that you've seen in this presentation um, below the video. Thank you.